Your business processes a large volume of data. You want to extract meaningful information from this data and create reports based on this data. You want to understand how SAP HANA can help you with your data storage and analysis needs today. You also want to make sure that SAP HANA can future-proof your organization in preparation for the expansion of the Internet of Things. By the end of 2009, 5% of the world's population owned smartphones. 4 years later, that figure jumped to 22%. Currently, 1.7 billion people are on social networks. Over the next 3 years, that audience will surpass 2.55 billion. By 2020, 5 billion people will enter the middle class and come online, while 50 billion devices will be connected to the Internet of Things, creating a digital network of virtually everything. And cloud computing, a $41 billion business in 2011, will grow to a $241 billion business in that same time frame. The exponential growth of mobile devices, social media, cloud technologies, and the amazing amounts of data they generate have transformed the way we live and work. In fact, 61% of companies report that most of their people use smart devices for everything from email to project management to content creation. While all of these advances have improved our lives and have provided us with greater opportunities for innovation than ever before, they have also accelerated the rise of an entirely new problem to contend with: unprecedented and crippling complexity that suffocates innovation. The world may be getting smarter, but it has not gotten any easier. Mass consumerization of IT means online purchasing, banking, completing online applications becomes commonplace. How much digital data did you create today? Part of this data might be of interest to some organizations, but they can only integrate it with their core business processes if they run SAP S/4HANA. With the existing system architecture, you have to make a trade-off, either going for a broad and deep analysis or speedy and simple reporting. With existing technologies, optimizing across the 5 dimensions shown in the figure is not possible. Therefore, you can decide to go deep and broad with your business warehouse systems or have high-speed but simple reports from your data. In both scenarios, real-time updates are difficult, almost impossible to design. In a data warehouse environment, updates occur overnight with nightly batch jobs. In the last few years, there have been significant advances in technology that application developers are able to take advantage of in order to build smarter and more powerful applications. For example, multi-core processors enable parallelism of tasks. This means more throughput of data and faster processing to give us real-time responses. Large memory enables us to fit an entire organization's database in memory. This means that we lose the mechanical spinning disk and the latency it brings. Advances in the design of onboard cache means that data can pass between memory and CPU cores rapidly. In the past, even with large memory, this was a bottleneck as CPUs were demanding more data and the journey from memory to CPU was not optimal. We can now easily slot in more servers into our landscape to add more processing power or memory in order to scale to any size. SAP rewrote their business application software to fully exploit the new hardware. SAP worked closely with leading hardware partners who shared the product blueprints of their new CPU architectures so that SAP knew how to write the very best modern software to extract every drop of power. Cloud computing technology has matured in the last few years and is now a compelling deployment option for our customers who do not want to take on the complexity and cost of the installation and maintenance of IT landscapes. Virtualizing machines means lower costs of running enterprise-wide applications. Public cloud services based on subscription models increase access to everyone to the latest solutions, reducing the costs and simplifying everything. For more than 20 years, organizations have been using specialist software, usually with additional hardware, to extract, transform, and load ETL data from transactional systems to dedicated reporting systems. Based on the technology available at the time, this was the optimal way to provide a holistic view of business data with good response times, especially when you add accelerator software or hardware. Online transactional processing, OLTP, was separated from online analytical processing, OLAP. The reason for this lies in the database design of OLTP and OLAP. Quite simply, a database model was either built for OLTP optimization or OLAP optimization, but not both. However, this also brought with it complexity, redundancy, and of course, latency. It was usual for today's business figures to be only available tomorrow for analysis once the data was extracted and loaded to a reporting system. The database, which supports SAP S/4HANA, SAP HANA, can handle both OLTP and OLAP processing from a single data model, and therefore we do not need to move transactional data to a separate system. This means transactional and analytical applications run off the same tables, and therefore data is available in real time at every level of detail. Traditional applications were built on a hierarchical data model. Detailed data was summarized into higher-level layers of aggregates to help system performance. On top of aggregates, we built more aggregates and special versions of the database tables to support special applications. So, as well as storing the extra copies of data, we also had to build application code to maintain extra tables and keep them up to date. Database indexes improve access speed because they are based on common access paths to data. But they must be constantly dropped and rebuilt each time the tables are updated. More code is required to manage this process. The traditional data model is complex, and a complex data model causes the application code to be complex. It has been found that up to 70% of application code is built specifically for performance of an application and adds no value to the core business function. With a complex data model and complex code, integration with other applications and also enhancements are difficult and simply not agile. Using the raw power of SAP HANA, we can aggregate on the fly in sub-seconds from any line item table. We don't need pre-built aggregates. SAP HANA can generate any view of the data at runtime, all from the same source tables. SAP HANA organizes data using column stores, which means indexes are usually not needed. They can still be created, but usually offer minor improvement. So in addition to losing the aggregates and indexes from the database, we can remove huge amounts of application code that deals with aggregates and indexes. We are left with a simplified core data model and also simplified application code. Now it is much easier to enhance the applications and integrate additional functions. Since the beginning of enterprise computing, SAP has been rebuilding the business applications whenever major technology shifts have occurred. The following are some key moments in development history for SAP applications. 1979. SAP invents ERP. SAP builds standard business software based on mainframe technology. The name SAP R2 supports and integrates major business functions in real time and handles multi-country and multi-currency implementations. R means real-time. There was an R1, but this was not regarded as the first major release. 1992. With the rise of the personal computer, the introduction of client-server architecture means another rewrite of the applications, so that we exploit the power of a layered three-tier architecture approach where processing is split across three layers of processing: client, application, and database. Out go the monochromatic, text-based, messy green screens, and in comes a new graphical interface to improve the end-user experience. This is the birth of SAP R3, 2004. By now, the web is firmly established as the common business network, and customers demand better integration with their business applications and the web. SAP develops a new integration application platform called SAP NetWeaver to enable this. Now all SAP applications run on a common platform, but also customers and partners can build and integrate existing applications easily using widely adopted web standards such as Service-Oriented Architecture, SOA. A new switch framework was later introduced to allow customers to selectively enable only the new functions developed by SAP in order to avoid disruption to their core processes. The SAP R3 name was changed to SAP ERP. SAP ERP is part of a larger family known as SAP Business Suite, which also contains many other line of business (LOB) applications from SAP, such as SAP CRM. 2015. A new wave of advances in hardware architecture brings massive computing power at decreasing costs. Huge memory and multi-core processors arrive to offer massive computing power. The underlying design of existing SAP applications does not fully exploit the power of the new hardware. A rewrite of the complete SAP Business Suite is required. The new Business Suite is called SAP S/4HANA. SAP S/4HANA is not a single product but covers many applications. Customers can start with the basic components and add to them later. S/4HANA Enterprise Management is a great place to start. This is known as the simplified core and can be considered as the replacement for SAP ERP. Here we find support for all core business processes such as quotation to cash, procure to pay, and so on. For many customers, this is where their S/4HANA adoption begins. S/4HANA Enterprise Management can be easily integrated with SAP S/4HANA Lines of Business (LOB) solutions. These options can be added at any time and provide best-in-class lines of business solutions and connections to SAP business networks. Customers can choose the LOB solutions that suit their businesses. In the past, we had multiple add-on applications surrounding the core with overlapping models and much redundancy. For example, SAP CRM and SAP SRM surrounded the core ECC. Now, overlaps and redundancy have been completely removed from SAP S/4HANA. SAP S/4HANA is built natively and optimally to run only on the SAP HANA platform. SAP S/4HANA is built on SAP HANA and so inherits all the capabilities of this powerful in-memory data management and application platform. This includes advanced text mining, predictive analysis, simulations, and powerful real-time decision support with access to any type of data in real time. A brand new user experience is delivered to improve the productivity and satisfaction of business users and brings the interface up to a consumer-grade experience optimized for any device. SAP S/4HANA can be deployed on-premise or in the cloud, or a combination of both, to provide flexible consumption options to customers. The data model has been simplified. This means unnecessary tables have been removed, and of course the data in those tables, in order to shrink the footprint dramatically and simplify the application design and extensibility. As an example of the reduced data footprint, you can move from a 7 TB ERP on any database down to an SAP S/4 system which requires less than a terabyte of data. This is achieved through aggressive data compression and system architecture simplification. It offers a higher throughput, 3 to 7 times faster at processing of your data. It is fully flexible without pre-configured indices, without pre-configured summarizations, and you can use your data in new ways that until now were impossible. It is enterprise software designed with big data and agility at its core. This section provides related SAP links. You are interested in the new SAP HANA technology, especially the new offerings in financials for S/4HANA. You want to know more about what is included, what infrastructure is involved, and the general terminology used. Traditionally, the SAP financial applications are separated into different components, for example, financial accounting, FI, management accounting, CO, and so on. These components are themselves made up of subcomponents such as asset accounting, FIAA. Each component has its own data model architecture, and this brings with it inefficiencies. The development of S/4HANA provided the opportunity for a complete redesign of these data models to remove inefficiencies. The development cycles for the architecture improvements have been constant. In 2012, it was possible to implement SAP HANA as an accelerator to sit side by side with the traditional stack to apply significant speed up to some selected applications. These included financial applications such as COPA. In 2013, it was possible to migrate a traditional non-SAP disk-based database to SAP HANA, so everything was running in memory. Accelerators were no longer required, so all applications benefited from fast in-memory processing. In 2014, SAP began the simplification journey by providing an add-in for finance that was part of Suite on SAP HANA, not S/4HANA. This streamlined the finance application. In 2015, SAP completed the simplification journey by fully redesigning the data model and code for S/4HANA Finance, which was the first major application of SAP S/4HANA. SAP HANA makes finance management simpler and faster. End users receive personalized information with a granular drill down to the line item. There are many ways to view and analyze data depending on the solutions implemented. Business intelligence products are also available that cover a full range of ways to represent data, renewed managerial roles that are specifically targeted to individuals like the financial officer or the receivables manager. In addition, SAP delivers renewed transactional roles for the end users, such as the general ledger accountant or the fixed assets accountant. SAP provides a fully integrated platform based on the latest technology trends to allow finance to lead the transformation to digital business. The figure shows the functional completeness of SAP S/4HANA Finance. All aspects of financial requirements across all roles are supported in granular solution areas. In the figure, you can see the scope of innovations in financials. SAP Accounting is the core of SAP S/4HANA Finance innovations. Instant insight to action is based on real-time information. There is a single source of truth on the most granular level, the document line item. There is no searching and second-guessing the source of data. Instant insight works with real-time processing and has no batches. The solution includes dynamic planning and analysis simulations throughout the period, and the data is always based on the latest information available at any time. There are two distinct product groups, SAP S/4HANA and SAP S/4HANA Finance. SAP S/4HANA Infinity is the main product development line. It refers to the complete suite and is where the innovations for all S/4HANA versions are first implemented. The innovations feed into the two basic full innovation suite offerings. SAP S/4HANA is the on-premise solution and has annual new releases, and during its lifetime receives a service pack, SPS, every 3 months. Note that the service pack of alternating trimesters is referred to as feature packs, FPS, as they add functionality. SAP S/4HANA Cloud is the cloud solution deployed either on a public or private cloud landscape, and a new release is delivered every 3 months. S/4HANA Finance is the add-on product that is installed on top of SAP Business Suite and updates only the financial architecture, no logistics innovations. It receives selective feature downports from the full SAP S/4HANA suite 3 months after these features are introduced for SAP S/4HANA. The S/4HANA Finance 1605 release will be updated every trimester. The older SAP Simple Finance 1503 switches to half-yearly service packs and will not receive functional enhancements. This section provides related SAP links. You are currently running an SAP ERP system and want to upgrade to use the functionalities of the latest version of S/4HANA. You want to know if your current system configuration meets the prerequisites and what kind of changes you must prepare for. Compatibility packs allow customers to use capabilities of today's classical portfolio and the capabilities of the S/4HANA OP 1511 release on one single S/4HANA installation. Only those classical ERP capabilities that are included in the compatibility pack are available for the S/4HANA installation and deliver the same functional scope as in a classic ERP installation. The current documentation of the classical ERP solutions for which a compatibility pack is offered for S/4HANA applies for all compatibility packs related to a separately licensed product today. For those related to the SAP ERP package, there is a separate feature scope description in the S/4HANA documentation, S/4HANA 1511 feature scope description. A compatibility pack is an S/4HANA compatible copy of SAP software the customer has already licensed or will have to license. The respective compatibility pack may be used by the customer according to the appropriate terms of the software use rights document. Customers must have or acquire licenses of the respective classical ERP capabilities from the classical SAP price list. Compatibility packs running in an S/4HANA installation have to adhere to the restrictions and follow the same release and maintenance strategies as any other S/4HANA application when used in an S/4HANA installation. Note: the same classic solution can also be deployed on a non-S/4HANA installation where S/4HANA restrictions do not apply. New SAP customers starting with SAP S/4HANA can use classic migration tools to take over their legacy data. The SAP Simple Finance migration tools work only for existing customers and systems. Depending on the active applications in the source system, different preparation steps are required. The description can be found in the SAP Online Help. The duration and effort is relatively small. The migration can be executed at any period end and is supported by a migration guide and monitor. No new GL or other migration service is required to migrate to SAP Accounting powered by SAP HANA. Migration scope is comparable to migration to new GL Scenario 1, merge of the FI ledger. The first test migration gives an indication of the duration and highlights any potential setbacks during the migration project. Migration to accounting on SAP HANA from a classic GL setup does not support the following scenarios: implementation of document splitting, balance sheets at the profit center level, migration from special purpose ledger to new general ledger accounting, new implementation of parallel accounting, new implementation of segment reporting, implementation of the ledger approach for parallel accounting, change in chart of accounts and conversion of chart of accounts, inclusion of customer fields, transfer of quantities to new general ledger accounting. Note: if you have started or are planning to start a migration to new GL using the SAP General Ledger Migration Service, we recommend that you complete the new GL migration project before installing the Simple Finance add-on. Required pre-checks. The program described in Note 2176077 checks customizing setting for GL, CO, and other components, except asset accounting. New asset accounting is the only asset accounting solution in SAP S/4HANA. The configuration and activation is on the client level. Both multiple valuation approaches are possible: ledger approach and account approach. Usage of the new depreciation calculation engine is mandatory, based on extension EAFIN Note 1498047. The program described in Note 1939592 checks if the new asset accounting can be installed. It is followed up by Notes 2156496, 2246638, and 2129306. These programs check the customizing for asset accounts, for example, ledger, currency, and evaluation plan. The new architecture does not support the following features: Lease Account Engine, LAE, Real Estate Classic, RE Classic, Public Sector Management, Funds Management, PSM-FM using requests, Application Link Enabling, ALE, Transfer of Assets. Coming from an SAP ERP system, you have several options to migrate to SAP S/4HANA. You can migrate your ERP systems one by one to S/4HANA systems. You can migrate and consolidate your ERP finance systems to one S/4HANA system. You can continue using your ERP systems but create an SAP S/4HANA system as a central finance system. All finance data of the source system is replicated to the central finance system, which you use for reporting and consolidation. This scenario also works with non-SAP source systems. A scenario for Central Finance option is described here. The benefits of SAP S/4HANA Finance are clear, but how do you get there? In a company that has a legacy of ERP systems, both SAP and non-SAP systems, the systems have different release levels, different customizing, and some even have different charts of accounts. The project that it would take to adopt the SAP latest innovations would be too large and expensive to get through a budget committee. The business challenges are as follows. Consolidated entity reporting, latent, high-level, aggregated management information, central process execution, missing economies of scale, no shared services, business model pressure, organic and non-organic growth mandate, heterogeneous IT landscapes, unyielding to modernization or transformation, SAP and non-SAP ERP systems, high consolidation, harmonization, reconciliation effort, relational database designs, data duplication, data redundancies, productivity and effectiveness. People cannot get the data that they need to make a decision. On the left of the figure, you see the source systems. These are the ERP systems that we do not want to change. They can be any release of SAP. Out-of-the-box functionality supports systems down to ERP 6.0. Older releases have to be integrated in a services project or a non-SAP system. Often they have been over-customized, making it too expensive to migrate or upgrade the system to take advantage of new innovation. Data is replicated using the SAP Landscape Transformation (SAP SLT) replication server. The SLT can be located on-premise or in the SAP HANA Enterprise Cloud. SLT can replicate data from SAP systems as well as non-SAP systems. It pulls the data directly from the database without having to adapt the programs in the non-SAP applications. There are specific functionalities that have been developed to help our customers use this Central Finance deployment option. There is a Central Finance accounting interface which reposts the following: FICO postings, CO secondary postings where the CO document is the leading document, for example secondary cost elements, certain cost objects, for example production orders, internal orders, and QM orders. Error correction capabilities for FI documents are provided by the Error Correction Suspense Accounting functionality. This provides a worklist-based approach for correcting replication errors or mapping errors. Once the mapping and checks have been completed, all postings go through the standard internal accounting interface into FICO in the SAP HANA database. Central Finance helps companies to report on financial figures sourced from different systems. These systems might be running Classic GL or the new GL. They probably have different customizing settings and no harmonized master data as follows: chart of accounts, controlling areas, operating concerns, material numbers, product hierarchies, customer or vendor numbers, cost centers or cost center hierarchies. There are 3 interfaces that feed data from the source systems into the target system's accounting interface as follows: an interface for reposting FICO postings. Financial documents that are posted in the source system are reposted as new FI documents in the central finance system. If these postings are relevant to CO, expenses on cost elements, CO will also be updated. An interface for reposting CO postings. This interface reposts CO postings where the CO document is the loading document. In contrast to the interface for FICO postings, these are postings that are not necessarily reflected in financials in the source system, sometimes only for reconciliation purposes. For example, postings on secondary cost elements. An interface for replicating certain cost objects, such as production orders, internal orders, QM orders, and so on. The posted documents are stored in the Universal Journal entry of the SAP Simple Finance add-on system. It is possible to take advantage of new GL features within the SAP Simple Finance add-on, as well as the ability of a flexible reporting based on line items instead of pre-aggregated totals. Furthermore, beautiful SAP Fiori user interfaces and reporting tools can be used in the central finance. Reporting with the speed of SAP HANA is available on line item levels. The Cost Object Mapping Framework manages short-lived cost objects. A cost object in the source system is mapped to an automatically generated cost object in central finance. Long-life master data is mapped either using SAP Master Data Governance, MDG, or another MDG solution, which can be in the same system or somewhere else in the landscape, or in the case of SAP MGD, deployed in SAP HANA Enterprise Cloud. For customers that do not have an existing master data governance solution, there are basic mapping tables in the solution for key master data, chart of accounts, customers, suppliers, and so on. There is also a business add-in, BADI, which can be used for customer-specific mapping logic. The new postings transactions replace use of existing BAPI_ACC_document_post. The postings have the following features: addresses limitations in older BAPI, better extensibility, industry solution inserts, custom fields, and so on. No longer limited to a 999 line item limit anymore. Utilized new ACDOCA in Simple Finance 2.0. Are only available for central finance use. The master data harmonization in existing distributed landscapes is a real challenge. Documents have to be forced to fit, and stocks have to be reposted or transferred. One major benefit of central finance is that before the reposting is performed in the central system, master data mappings can be performed. This allows harmonizing the different master data of the various source systems on the fly. As a consequence, a harmonized financial reporting can be achieved across the entire group. The new system will be clean. The following is a summary. Replication via SAP SLT. Transaction-based, not table-based. Requirements: system configuration and customizing, master data synchronization, chart of accounts, and so on. Restrictions: centrally executed processes must not result in back postings to the source systems in order to maintain the integrity, completeness, and so on, and legacy system status of those systems. The amount of configuration, customizing, and master data synchronization required in the central finance depends on the type of process desired. Many scenarios, especially core GL scenarios, are achievable with limited effort. More complex scenarios or scenarios beyond core GL finance might be challenging or in selected cases not feasible. In the document header of the newly posted FI document in the Central Finance or Target system, new fields have been added to reference back to the original FI document. By double-clicking the reference document number, it is possible to navigate back to the source ERP system to view the original FI document. The following are SAP notes for Central Finance. SAP Note 2148893, Central Finance, Implementation and Configuration, contains information and documentation about the installation and configuration of Central Finance, lists all relevant notes that need to be implemented in either the source systems or the Central Finance system. SAP Note 2184567, Central Finance, Frequently Asked Questions. Note: we recommend that you regularly search OSS for notes on component FICF recurring exercise to get full coverage. All notes to be implemented in latest version, recurring exercise as well as updates, new versions happen quite frequently. The following are SAP notes for Application Interface Framework AIF General. SAP Note 2071823. ABAP Add-on AIF 702, Installation, Upgrade, CSPs. SAP Note 2071952, ABAP Add-on AIFX 702, Installation, Upgrade, CSPs. SAP Note 1530212, SAP Application Interface Framework FAQ. The following are SAP notes for AIF for Central Finance. SAP Note 2196783, Central Finance, Error Handling with AIF, Corrections. SAP Note 2202650, Central Finance, Error Handling in AIF for Replication of FI Documents, BC Sets. SAP Note 2202691, Central Finance, error handling in AIF for replication of CO documents and cost objects, BC sets. For SLT general information, refer to the SLT Wiki. For information about SLT for CIFN, see SAP Note 2154420, SAP Landscape Transformation Replication Server for SAP Central Finance. Note: if source system uses a third-party database with a runtime database license, the business integration scenario in SLT must be used, which requires certain steps to be performed that are explained in SAP Note 2223621, Central Finance Interface for Business Integration. For information about SLD for CIFN, see SAP Note 222508, Enabling Central Finance Business Mapping without the need to set up Systems Landscape Directory, SLD. Restrictions in Central Finance option are described here. The figure shows the use cases along the product maturity level. After the start of production, the structures and data for cost valuation are available. The engineering BOM is transformed to the manufacturing BOM. The integration of the controlling, finance, and logistic data, such as production planning and purchasing, allows you to evaluate stocks of a material and to analyze the actual data easily. Before start of production, the structures and data are incomplete. There is a need to calculate and simulate costs for new products in changing business environment and against target cost and play with what-if scenarios. Here we distinguish three use cases as follows. Preliminary cost estimate is typical for new product development of standard products. You create a costing structure and prepare preliminary cost estimates even at the early stages of product development when you lack detailed information such as master data or prices. The first structures are often document structures and later the engineering BOMs. Quotation costing is typical for engineered products in ETO or design-to-order scenarios. You create cost estimates for unique and complex products that are designed to existing customer specifications. Often, past cost estimates of similar products or solutions are used as base and adopted to the specific customer needs. Lifecycle costing is about evaluating and optimizing costs during each phase of a product lifecycle. To reach maximum profitability, you create different calculation versions from the initial idea through the start of production and throughout the manufacturing process until product disposal. You can calculate and evaluate one-off costs and special costs associated with warranties, service and support, and disposal. You can also analyze direct material and manufacturing costs, define cost reduction targets, and support procurement and manufacturing operations. The primary focus industries are the discrete manufacturers, for example, automotive, high-tech, industrial machinery and components, aerospace, and defense. SAP Product Lifecycle Costing is a solution that calculates costs and other dimensions for products and quotations in an early stage of the product lifecycle to identify cost drivers along the lifecycle quickly and to simulate and compare alternatives easily. You can calculate costs quickly and precisely. You can simulate and compare alternatives to gain better visibility and control throughout your product lifecycle. This transparency helps you to identify costs and harness cost-saving potential. You can optimize product quality, drive profit margins, and mitigate future risk to make the most favorable product costing decisions for the entire lifecycle of your products. We listened to our co-innovation customers and identified the major requirements: performance, usability, and leveraging the ERP data. The following are the characteristics of our solution to meet these needs. Real-time SAP HANA. SAP Product Lifecycle Costing is based on the SAP HANA platform. Product costing is a real SAP HANA case to increase performance and transparency in complex structures. User-centric. Our co-innovation customers told us that cost controllers love Microsoft Excel, so we provided an MS Excel-like UI. The front-end software component is a Microsoft .NET Framework client application. Open. You can use SAP Product Lifecycle Costing standalone or integrate it with your existing solution landscape to calculate variables of cost in real time using data from your enterprise software. You can integrate ERP and PLM data or import data via MS Excel. In addition, we provide extensibility option to integrate to other systems using APIs. We will talk about this later in detail. Flexible cost structure. The flexibility is key in the early product costing. You can create cost estimates even when structure and values are only partially available by taking into account the variability of material, labor, and overhead costs. The following is a list of the key capabilities of SAP Product Lifecycle Costing. Real-time calculation engine. Integration with SAP ERP to import data and structures such as bills of materials, BOMs, routings, and standard prices. Import of existing structures including BOMs and routings from Microsoft Excel. Master data management to manually maintain and use data that is not yet available in SAP ERP. Early calculation of costs for new products before complete structural data and prices are available. Calculation versioning to compare costing alternatives. Constant refinement of data throughout the entire product lifecycle. Different price determination strategies. Confidence level that measures the reliability of a cost estimate for the item. For example, prices that are entered manually receive the lowest level of confidence versus standard prices from ERP. Flexible foundation for reporting and analysis, including standard, self-service, and custom reporting. There are 3 views offered by the solution, each for specific purposes. The cockpit view, shown in the middle of the figure, is the main entry point for calculations. You can use the cockpit to manage calculations and corresponding versions and see details such as total cost and total quantity, the user information, and timestamps. The calculation view is a central point to work with calculation versions. This view consists of several main areas as follows. Costing structure. This is the hierarchical tree structure at the left in the view. This structure shows all of the items that are currently included in a calculation version. Calculation table. In this spreadsheet-like table in the center of your screen, you can enter the cost for each item, including price, quantity, unit of measure, overhead, and other relevant costing information. Key figures. In the Key Figures area at the top right of your screen, you can keep an eye on the total cost and total quantity in each calculation version. Side panels at the right, such as the following. Version header details show general information about a calculation version, such as version ID or version name. The calculation ID, calculation name, and controlling areas fields logically belong to the calculation and are therefore identical in all versions of a calculation. Item details. After selecting an item in the costing structure, at the left, you can view and modify information for the selected item in this area. The administration view is the central point to maintain the master data and global settings. Master data includes logistics, controlling, and finance data like material-related data, activity rates, costing sheets, cost component splits, and so on. Master data can be replicated from your SAP ERP system or defined locally in SAP Product Lifecycle Costing. The administration view gives you an overview of the available master data and shows you the source of the respective data. Global settings are languages, currencies, units of measure, and global default values, controlling area, company code, plant, reporting currency, cost component split, costing sheet. A costing structure is a hierarchy which consists of items to be costed. These items can be based on different types of product-related structures such as document structures, bills of materials, BOMs, and routings. You have different ways to create a costing structure as follows. SAP Product Lifecycle Costing can be integrated into the SAP landscape. Existing document structures, bill of materials, and related routings can be easily imported from SAP ERP. Furthermore, you can import quantity structure from Microsoft Excel documents to create a calculation as a whole or to update an existing calculation at every level. In addition, you can add items to a costing structure manually, such as materials, processes, resources, and activities that are used to make a finished or semi-finished product. When creating a costing structure, you can activate and deactivate items to simulate alternatives in your calculation version. SAP Product Lifecycle Costing offers different options to help you set prices and rates for items and rates for activities in your calculation versions. You may need to work on your calculation version even if some master data is not yet available or has not yet been finalized. You can create items in the cost structure that do not yet exist in the master data. Once the material is available, you can return to your calculation and add the missing data. You can use master data that has either been defined locally in SAP Product Lifecycle Costing or replicated from your SAP ERP system. If a price or rate exists in your master data, it is applied automatically in your calculation version. You can also set prices and rates for items in a calculation version by selecting a price source or by entering the price manually. At any time when working with the cost structure, you can analyze the choices that you made regarding materials, processes, activities, prices, quantities, overheads. You can do this by using cost component splits. You can analyze the breakdown of costs for each item and identify the major cost drivers. The cost component split updates automatically with every change. In addition, you can apply any of the cost component splits that you have created in master data to any item at any time. Another option to analyze cost is using the costing sheet. The costing sheet defines how overheads are determined and how sums are calculated. The values calculated by the costing sheet are shown for every item that you select. You can select the costing sheet that you want to use in a drop-down list. If you do not want to calculate overheads or sums, you do not need to use a costing sheet. In addition to the described in-tool analysis options, you can use SAP HANA views to create your custom reporting. This leads us to the extensibility options. SAP Product Lifecycle Costing is designed to fulfill a wide range of standard requirements. However, we know that our customers have specific needs and many additional use cases that require to enhance our solution to these specific needs. Therefore, we considered several technical options to extend SAP product lifecycle costing and integrate it with external applications. Back-end APIs are ideally suited for process automation and system integration. You can use APIs to access any PLC functionality from a third-party application via HTTP or REST or JSON-based programming interface. Front-end or client application is not needed. Example use cases of back-end APIs include the following: automatically upload costing structure from third-party application into PLC, perform calculation, return results. Upload or download master data. Custom mobile application showing data available in PLC. SAP HANA views can be used to create reports. You can use a set of standard views or create custom views on top of database tables and implement business logic to create a meaningful report. These views can be consumed via Java or HTML-based applications or SAP HANA native applications. You can use SAP tools like SAP Lumira or Analysis for Office to directly connect to SAP HANA and run reports and perform your analysis. It is also possible to use third-party tools like MS Excel to connect to SAP HANA and create your own reporting. These options are available in version 1. The next two options are already planned. Custom fields and formulas are applicable to add fields and to define calculations. For example, you can add custom fields for length, height, width of a material and calculate volume and quantity of raw material needed. Finally, we will offer to extend PLC with custom functionality in the front end via a C#-based add-in framework. For example, you can add custom dialogues, side panel sections, import options.